Something is wrong with Uranus, and scientists didn't expect it. For decades, it was labeled the most boring planet in the solar system. Calm, frozen, lifeless. But recent observations are telling a different story. Storms are appearing where they shouldn't. Its magnetic field behaves like it's broken. And deep inside, there may be a form of matter that doesn't even exist on Earth. Here's the unsettling part. We've only visited Uranus once. One flyby. In 1986. What if everything we think we know about this planet was based on the worst possible timing? Because by the end of this video, you'll see why Uranus might be the strangest world we've completely misunderstood. Uranus doesn't spin like other planets. It rolls, tilted 98 degrees. Imagine Earth knocked sideways, oceans shifting toward the poles. Scientists believe something massive struck it billions of years ago. Possibly a planet-sized object. A collision powerful enough to tip an entire world over. But here's the problem. If something hit Uranus that hard, why does it look so stable? Its rings are still there. Its moons orbit normally. Nothing looks violently disturbed. It's like a catastrophic event happened. And then everything settled perfectly. Almost too perfectly. Because of that tilt, Uranus experiences the most extreme seasons in the solar system. Each season lasts 21 Earth years. One pole faces the sun for 2 decades straight. Then it falls into darkness for 2 decades. You'd expect dramatic temperature shifts, atmospheric chaos, massive storms triggered by that energy imbalance. But Uranus barely reacts. Its temperature stays strangely uniform, which leads to the next mystery. Uranus is colder than Neptune. That shouldn't happen. Neptune is farther from the sun, yet Neptune radiates internal heat. Uranus barely does. It's as if its internal engine shut down. Did the ancient impact knock the heat out of it? Did something change deep inside? Or is its interior built differently from what we think? We don't know, because we've only seen it up close once. In 1986, Voyager 2 flew past Uranus. It remains the only spacecraft to ever visit. The images came back. A smooth pale blue sphere. No dramatic storms. No violent bands. Scientists quietly labeled it dull. But here's the detail that changes everything. Voyager arrived during Uranus' summer. One pole was pointed toward the sun. We saw one season, one snapshot, out of an 84-year orbit. What if we judged an entire planet while it was asleep? Decades later, telescopes began watching Uranus more closely. And something changed. Bright storms started forming. Cloud systems intensified near the poles. Atmospheric activity increased as it approached equinox. This wasn't supposed to happen. The boring planet wasn't boring anymore. It was dynamic, unpredictable, alive, which means our original conclusion may have been wrong. And if we were wrong about its atmosphere, what else did we misunderstand? Most planets have magnetic fields aligned with their rotation. Uranus does not. Its magnetic field is tilted 59 degrees, and it's off-center. That means as Uranus rotates, its magnetic field swings wildly through space. Radiation belts shift. Auroras appear in strange places. Its magnetosphere behaves like it's unstable. Scientists believe this could be caused by something unusual deep inside. Something we've never directly observed. Under extreme pressure, water behaves differently. Deep inside Uranus, there may be a layer of superionic water. Not liquid, not solid. A strange state where oxygen forms a lattice. and hydrogen flows through it like electricity. If that layer exists, it could explain the chaotic magnetic field. But we don't know for sure, because no probe has ever entered its atmosphere. Everything we believe is based on distant data and a single flyby nearly 40 years ago. For such a massive planet, that's surprisingly little. Ice giants like Uranus are common across the galaxy. Many exoplanets we discover are similar in size. If Uranus behaves differently than our models predict, then we may be misunderstanding one of the most common planet types in the universe. That's not a small error. That's a foundational one. And the key to solving it is right here in our own solar system. Waiting, there are proposals for a dedicated Uranus orbiter, a mission that could finally map its gravity, study its atmosphere over time, and analyze its magnetic chaos up close. But it won't launch anytime soon. Which means for now, Uranus remains a mystery, a sideways world with suppressed heat, a broken magnetic field, storms we didn't expect, and secrets we've barely begun to uncover. So here's the question. Did an ancient collision permanently change this planet? Is its interior unlike anything else in our solar system? Or did we simply arrive at the wrong moment and misunderstand an entire world? Until we return, Uranus is still keeping its secrets,